Picture this. 4 guys, muscles straining, trying to drag a 500-pound set of heavy steel tongs across a wet, totally slippery rig floor. I mean, that is exactly how you get a crushed foot, a wrecked back, and potentially a career-ending injury, right? Now scratch that mental image and watch this instead. One single hand squeezes a simple lever, and that exact same 500-pound load just floats up into the air like it weighs absolutely nothing. Welcome to this explainer. Today we're diving into the massive difference between raw, dangerous physical labor and controlled mechanical power. We're talking about a squat little drum bolted to the rig floor that runs on literally nothing but compressed air. We're talking about the air hoist, the undisputed muscle of the rig floor.
So let's really look at this visceral contrast. The traditional, dangerous way involves a whole crew straining to drag a massive load. And let's be honest, a wet rig floor is simply no place for muscling half a ton of steel by hand. But with the modern solution, one hand effortlessly lifts it with a lever. The air hoist completely replaces dangerous physical exertion with smooth, mechanical power. It basically takes all that physical strain off the crew and transfers it right onto a machine that's specifically built to handle incredible weight.
Section 1. What is an air hoist? The pneumatic winch.
An air hoist, which, by the way, you'll frequently hear called a tugger out in the field, is a winch driven by compressed air instead of an electric motor. It just spools a wire rope onto a drum to lift and drag heavy objects. It's the absolute go-to tool on the rig floor for handling joints of pipe, heavy tong assemblies, toolboxes, pumps, you name it. Basically, if an object is just too heavy for the crew to safely muscle by hand, but it's kind of too light to justify firing up the massive Drawworks, the air hoist is exactly what you reach for. It's small, it's fast, and it is always within arm's reach of the driller.
Moving right along to Section 2, how it works. Air, gears, and drums.
The linear flow of power here is actually pretty fascinating. The power source is the rig's compressed air system, which is a ring main feeding the whole floor at roughly 120 psi. That high-pressure air gets piped directly into the hoist's air motor, usually a vane or piston type. As that air rapidly expands inside the housing, it violently spins a shaft. That spinning force then hits the gearbox, which drops the speed but massively multiplies the torque. And finally, that torque turns the spinning drum, spooling the wire rope. It is incredibly elegant. Push the lever one way, the expanding air drives the motor forward. Push it the other way, it reverses. And the best part? If you let go of that lever, the whole thing stops dead. Pure control.
Section 3. Where the lifting happens. Busiest points on the rig. Now you won't just find one of these tucked away in a dark corner somewhere. They are strategically mounted at the absolute busiest handling points. You're generally going to find them mounted right beside the V-door, exactly where incoming pipe comes up from the catwalk. You'll also see them positioned near the pipe racks to help shift those heavy tubulars. And you'll frequently find one mounted high up in the derrick. This brilliantly illustrates the ultimate safety goal. The derrick hand can hoist tools right up to the monkey board, ensuring that literally nobody ever has to climb a ladder while carrying a heavy, dangerous load.
Section 4. The rope layer trap. The hidden physics of capacity.
Okay, I want to test your rig floor intuition for a quick second. Imagine your air hoist has a stamped metal plate rating it for a 3,000-pound lift. You look over at the drum, and you currently have 4 layers of wire rope wound onto it. So, what can you safely lift right now? Pause and really think about it. Is it still 3,000 pounds?
Well, the actual answer usually catches people totally off guard. On the first layer, yeah, you get your full 3,000-pound capacity. But by the 4th layer, your capacity plummets to around 2,000 pounds. Why does this happen? It's just physics. As the rope builds up layer by layer, the effective radius of the drum grows larger. You're basically increasing the lever arm that the load is pulling on, but the air motor's torque stays exactly the same. So more radius equals less lifting power from the exact same air pressure.
So, the crucial point to remember here is this. Rated capacity equals the first layer only. This is a layered capacity trap that catches even highly experienced rig hands. If you absolutely must lift a heavy load that approaches the hoist's maximum rating, you can't just hook it up and pull. You have to spool that wire rope off the drum first and make your heavy lift on a low layer.
Section 5. 3 rig floor killers. Fatal mistakes to avoid.
It's a pretty sobering fact that these machines demand absolute respect. Because of their incredible power, the air hoist has one of the worst injury records of any small tool. There are 3 fatal mistakes you absolutely must avoid. First, standing under a suspended load. Never ever do this. If the brake slips or the line parts, gravity always wins. Second, letting the rope go slack.
When you let the line slacken, the load swings, instantly turning half a ton of steel into an uncontrolled wrecking ball. And third, using a frayed or kinked wire rope. The rule here is absolute, guys. If you can visually see broken wires on that rope, the hoist is out of service. Full stop. You just don't use it.
Section 6. The hidden reason. Why air?
All right, prepare for a real aha moment regarding rig floor logic. We've talked all about lifting power, capacity drops, and safety rules, but why use air in the first place? Why not just use a heavy-duty electric motor, kind of like a winch on the front of a tow truck? Well, if you look at an electric motor, it creates sparks and poses a massive fire danger. But an air motor produces absolutely zero sparks. A rig floor can have explosive gas or oil vapor in the ambient air at any given moment. An electric motor, by its very nature, generates sparks inside its housing. An air motor simply cannot spark. It is physically impossible. So the reason this powerful tool runs on air isn't for convenience. It's strictly to prevent a catastrophic blowout or fire.
And this vital fire safety logic applies across the entire board. That 120 psi air ring main powers all floor tools for spark-free safety. In a real hazardous area rig environment, you're going to find every single hand tool, the hoists, the massive heavy-duty wrenches, the Kelly spinners, all of them running on that identical compressed air system. It's an invisible, reg-wide safety network designed for one single purpose, keeping ignition sources as far away from explosive gases as possible.
So, let's quickly summarize the core takeaways of this explainer. The air hoist effortlessly lifts heavy loads, taking the physical danger completely out of the equation. But you've got to remember that its rated capacity drops significantly as rope layers build on the drum. Because it is so powerful, it demands strict adherence to safety rules. Never stand under a load, never let it swing, and never use a frayed rope. And finally, its most crucial design feature, it operates purely on compressed air to prevent deadly explosions.
Which brings us to our final, somewhat provocative thought for this explainer. Is convenience compromising your invisible safety systems? You know, when we use a reliable tool every single day, it just kind of becomes part of the background. We forget the profound life-saving engineering logic, like explosion prevention, that dictated its design in the very first place. So the next time you walk past an air hoist or really any other piece of everyday equipment, ask yourself, what other incredible, invisible safety features are you walking right past without even noticing? Thank you so much for joining me on this explainer. Keep asking questions and stay curious.